In today's video, we are going to go over triangles. And now the last few videos were on Euclidean geometry, was actually on straight lines. But triangles are actually not too far apart from straight lines, but at the same time they kind of are. So first of all, what is a triangle? What is this? What do we mean by a triangle? What does it look like? I'm pretty sure you people have seen it before, seen it in primary school, pre-primary school. But a triangle is basically, or technically, three lines that are connected to each other. So there's one line, there's another line, and then there's another line. Maybe I should just draw a better triangle. Okay, I think this is a better triangle. Okay, so as you can see, we have a triangle is a shape that has three sides. And the previous videos when we worked with straight lines, that's just one side, literally just 2 points that make up a straight line. But in this case, how do we actually look at a triangle in geometry now, in Euclidean geometry? When we looked at a straight line, we actually just called a straight line like this, and then we labeled it. For example, two letters, we labeled the one point A and the other point B, right? But now, what we are going to do, instead of just naming 2 points over here, we are actually going to label 3 points here. Now, you may be thinking that there is actually going to be about 6 different letters, because looking back at a straight line is going to have 2 letters. Now you're thinking, oh, if there's 3 straight lines, it's going to be 6. No. Now, I'm going to show you why not. So we basically have, let's name this point A over here. And then let's name this other point B. And let's name this point C. Okay, so now as you can see, we basically have 3 straight lines, but as you can see, at this point over here is point B, this is point A, and this is point C over here. And this is what we call, this line over here, we call line AC. This point, or this line over here of this triangle, we call AB. And then this line over here, we are going to call BC. Now, as you can see, one point or the one letter actually shares 2 different points for each straight line that is represented in the triangle. And that is what is meant over here. We only have 3 different points and 3 different lines, basically. 3 different straight lines in this triangle. That is just if you look at it in a Euclidean geometry type of way. Okay, now we actually can get into the angles. Now let me just get rid of all of this other stuff, and let's get into how do we represent angles now in a triangle. If it wasn't too obvious, obviously an angle looks something like this. And then here's another angle. And then here's another angle. Now, how do you represent these angles? With lines, when we represent, how do we name lines? When we name lines, we name them upon 2 letters. A letter where the line starts. So if we have AC, this is our line AC, which is this line over here. That is naming lines. But how do we name angles? This is how we name angles. We are either going to, for a triangle, as you can see, here is our point over here, right? We have 3 points. We have that point, and we have that point. And take note, we call these points the apex. That is just another fancy name that we can call it. You can still call it points, but I think apex is probably the best word to use. So, yeah, how do we actually represent angles? How do we name them? So as you can see, if we look at A over here, right, there's actually 2 ways we can represent it. We can represent it as A with a hat on top of it. Now, the A with the hat on top of it, the hat on top just means we are working with that specific angle. And if you want to name, we can actually name it in another way. We can say B, A, C. And take note, we have to have the hat in the middle. So basically, our angle that we're working with is going to be in the middle of the 3 letters that we have over here, or in the middle of the 2 letters over here, B and C. And what does that tell us, right? As you can see, for this A over here, we work specifically with this angle A right here, because you can see this is angle A over here. But if we're working with this entire BAC, this angle BAC, that's how we name it, we are actually talking about from this point over here, going all the way to A, and then it stops there, and now it goes all the way to C, and then it stops here by C. That is how we name angles. And a much more preferred, which one is actually the best out of the 2 of them? I'll show you which one. Well, I'll just give you the answer. I think the best one, or no, the best one to use is actually the second one, because it's more specific. If you're getting a triangle, which I'm actually going to go forward when we're doing examples, you'll see why this one is like that. But this is an introduction. I'm not going to go too much into depth. So the second one is going to be mainly used whenever you're doing examination questions, because it's more specific than angle A. As you can see, angle A is very vague. It's not much information that we can get from just angle A when we work with more than one triangle. That's just a little spoiler over there. Okay, now our final part of the triangle introduction, or I guess second part, our not final part, but our second last part of this triangle introduction is going to be, we are going to be naming different types of triangles. And yes, of course, triangles have names. There are different types of triangles, but I'm actually going to just draw them individually and show you how they would actually look. Okay, so the first triangle we are going to be dealing with is the equilateral triangle. Okay, so with the equilateral triangle, we have the following. As the name actually says over here, we have the word equal. Well, it's the word equal, but it's not exactly spelled equal. But an equilateral triangle means, and you must just remember these properties. These are the properties of the triangles. We have, let's say over here, if it can allow me to do the lines. Okay, so we have this line over here, this line of the triangle. It's not going to be the best looking triangle that exists, but it's fine. An equilateral triangle is a triangle where every single side is equal. And this is an introduction to these signs over here. What do these signs mean? These signs indicate that the sides are equal, depending on how many different symbols you have, or signs you have over here. If all of them have one stripe, that means this is an equilateral triangle. That means all of the sizes are the exact same to each other. Okay, now what happens if I do the following? Let's add another stripe, but like this over here. So we said that an equilateral triangle was where every single side is the same. And actually, there's one more property for this equilateral triangle, and I apologize for almost forgetting. Equilateral triangle is a triangle that has every single side that is the same, and every single angle is the same in this triangle. That is the property of an equilateral triangle. So in summary, this equilateral triangle, every single side of the triangle will be equal to each other, and every single angle of the equilateral triangle will also be equal. So I'm just going to write here, so you can take your screenshots if you want to. Sides are equal, and then let's say 3 sides equal, and then 3 angles are also going to be equal. Okay. So we're going to move on to the next type of triangle that exists. Okay, so our second triangle or second type of triangle we have is an isosceles triangle. There's a funny spelling, but we call this an isosceles triangle. What is an isosceles triangle? So if you remember, the equilateral triangle has all sides equal and all angles equal. But what makes an isosceles triangle different is that not all the sides are equal. So this triangle is more to scale, and I tried to make it as perfect as I could. But in an isosceles triangle, please remember that only two sides will be equal. So this side will be equal and this side will also be equal. We can see the scale of it clearly, that these two lines are the same length. And because that is true, and this is going to fall a part of one of our reasons we're going to learn later on, in a later on video, is that this angle over here is then just going to be the same as this angle over here. This angle and this angle are both the same as well. So therefore, with the isosceles triangle, we're going to have the following information. The information that we have over here is that only two sides are going to be equal and two angles are going to be equal as well. And take note where the angles are. These angles are opposite each other over here as well. This is just a hint towards the video that we will be doing. These are angles that are opposite each other. And yes, there will be more detail with the reason that we'll go over later on. Let's go to the next triangle and the last type of triangle we need to know. So this triangle right here is a very funny looking triangle, I'll be honest. Now, what is a scalene triangle? Now, a scalene triangle is, as you can remember from an equilateral triangle, an equilateral triangle is where all the three sides are equal and all three angles are equal as well. An isosceles triangle is when only two sides are equal and two angles are also equal. Now, what can you imagine a scalene is going to be? It's going to be everything but the ones we just went through. So therefore, every single side, this side is not going to be the same as this side. And this side over here is also not going to be the same as this side. And this is what I also wanted to point out, is that the different use of signs over here indicate, so yeah, these indicate which sides are equal to each other. And because all of them are different, therefore we can actually conclude that all the sides are not equal to each other. And that is what a scalene is. A scalene triangle is when every single side is not equal at all. No sides in the triangle are equal. And therefore, with the angles of the scalene, we can also conclude that none of the angles are equal either. That's what we can say about a scalene triangle. So, in a scalene triangle, absolutely no sides are going to be equal, and no angles are going to be equal either. And that's what we can say about a scalene. So those are the different types of triangles that we have. Okay, the last thing that I want to actually go through right now, and this is actually the most important property to actually know about every single triangle. And every single triangle will have the same property, no matter whether it's a scalene triangle, isosceles, or equilateral triangle. But every single angle, whether it's this one, and that one, it can be any angle that exists, but all the angles, so every angle, all angles must equal to 180 degrees. So every single angle must be equal to 180 degrees. This is the most important rule that you must know, and this actually is going to be an introduction to our next video, and it's going to be on our first reason, and our first reason will be the sum of all angles within a triangle. So stay tuned for the next video, and that video is going to explain in detail, as well as examples, what does it mean by the sum of all the angles in a triangle, and what must that equal to?